Finding your way around. How you navigate around a Moodle site will depend upon the administrator's settings, your theme, and how up-to-date your version of Moodle is. Our Learn Moodle site uses the latest version of Moodle and a theme called Boost. If your organisation's Moodle site looks different, ask your administrator to help you find a set of tutorials from our Moodle HQ YouTube channel that will fit your version of Moodle. Let's log in. Often, when you log in, you're directed to a personalised, customisable page called your dashboard. Here, you'll see an overview of the courses that you're enrolled in. We explore this further in our video called Dashboard. Over on the left, you'll see a navigation or nav drawer with useful links, for example, to your site's front page or site home. Perhaps your administrator directs you to the site home when you log in which case you can access the dashboard by clicking the link in the nav drawer. This nav drawer also allows you to see the courses you're enrolled in, so you can access them either by clicking the link in the nav drawer or the link in the course overview. The nav drawer can be collapsed or closed by clicking the hamburger icon top left to free up more space. You can open it again by clicking it again. Over on the right is a user menu, also with useful links. For example, in your Preferences page, you can edit your profile, change your password, select the language you want Moodle to display in, and decide the text editor you want when typing in text. As with many modern websites, you have icons for messages and notifications. From the Messages menu, you can read and send messages, manage your contacts, and from the cog, select who you want to exchange messages with and how to be notified of new messages. Notifications works in a similar way. You can view notifications, mark them as read, and from the cog icon, access your preferences. Let's go back to the dashboard, and now let's go into our user Sam's practice course where she's learning how to teach with Moodle. We can either click the link in the nav drawer or the link in the course overview. Once inside the course, notice that the nav drawer links have changed to reflect what's happening in the course. There's a participants link, badges link to see which badges are available, grades, and the topic numbers here are for sections within the course. We'll look at how to edit and explore these in a later video. Further down again, she can access her dashboard, site home, and other courses she's enrolled in.
Welcome to the presentation on derivatives. I think you're going to find this is when math starts to become In this video, I want to familiarize you with the idea of a limit, which is a super important idea. It's really the idea that all of calculus is based upon. But despite being so super important, it's actually a really simple idea. So let me draw a function here. Actually, let me define a function here. A kind of a simple function. So let's define f of x. Let's say that f of x is going to be x minus -1 over x minus 1. And you might say, hey, Sal, look, I have the same thing in the numerator and the denominator. If I have something divided by itself, that would just be equal to 1. Can't I just simplify this to f of x equals 1? And I would say, well, you're almost true. The difference between f of x equals 1 and this thing right over here is that this thing can never this thing is undefined when x is equal to 1. Because if you set, let me define it right, let me write it over here. If you have f of, sorry, not f of 0, if you have f of 1, what happens? In the numerator, you get 1 minus 1, which is, let me just write it down. In the numerator, you get 0 defined. But what if I were to ask you, what is the function approaching as x equals 1? Well, you look at this definition. Okay, when x equals 2, I use this situation right over here, and it tells me it's going to be equal to 1. Let me ask a more interesting question, or perhaps a more interesting question. We're getting to 4. So once again, that's a numeric way of saying that the limit as x approaches 2 from either direction of g of x, even though right at 2 the function is equal to 1 because it's discontinuous, the limit as we're approaching 2, we're getting closer and closer and closer to 4.